We are live, the Blockchain Center here in New York City and Miami. My name is Eric, and I am here with Jackson Belove of Quantum. Hello.
Hello, hello. Hey, Eric.
Hey, what's going on?
Thanks for the invite. Looking forward to talking with everyone, showing them a little bit of Python on the blockchain today.
Yeah, that's like honestly two of my favorite things. And that's why when I was told that we were trying to do something like this, I was like kind of ecstatic because it was like, all right. Because sometimes we jump around from like Python to Rust to Node, and sometimes we jump to a language that I'm not the strongest in. And when I heard that we're doing Python, I was like, great.
Yeah. You probably know. I'm, I'm, I'm thinking I probably know 25-30% of Python because I only
Sure.
learn what I need
Mm-hmm.
to to complete a particular task, and then I'll go research and figure out if I need to add something to that.
For sure. Yeah, and Python is so ubiquitous. So it's nice to have that inside your toolkit.
Yeah, I've used it a lot for screen scraping types of programs, APIs, and
Mm-hmm.
of course, as we'll be looking at tonight, interfacing with the node for blockchain work.
Yes. So we're doing something kind of like a scrape. You said you wrote a Ripper before, correct? That's what the name of it is, the Ripper.
Yeah, I generally call them a blockchain ripper, like,
Mm-hmm.
ripping music from a CD, if you know what that is. You may not be old enough to know what that is.
For sure.
Um,
No, I was there. I was there. I definitely
okay,
ripped CDs.
so I like to rip the blockchain and then do some crunching on it and try to figure out what's going on.
Cool. So it's more what I was. So you said you mentioned something about you were at the blockchain center when it was over in New York City.
Yeah, so I'm in New York City, and
Mm-hmm.
I remember the old days uh, going to the blockchain center when it was right hard on the New York Stock Exchange on Wall Street.
Oh yeah.
And that was a great location. And they would have live trading. They'd get these trader guys with their jackets on to come over from Wall Street. And there was, at the end of a session, open outcry Bitcoin trading
Mm-hmm.
um, on Wall Street. This was maybe 3 or 4 years ago, maybe longer. It was crazy, but it was a very interesting time.
Yeah. So I thought that was all a pretty cool part of history that you were a part of. And right now we are in the middle of redoing the new blockchain center, and we're just putting on the floors right now.
Is it on
So
the west side of Manhattan?
yeah, the Upper West Side.
Upper West Side. Okay, that's a nice area too.
Mm-hmm. So it's kind of like we're in that rebuilding period, and it's gonna look really nice. There's like a right now there was an art gallery that had like sand, so we're making like sand sculptures and sand garden while we're trying to decompress. It's funny.
Yeah.
So let's jump into it. I have the screen up here, and this is Quantum. What what are we going to be? What is Quantum first, and then we can move into what we're actually doing.
Sure. Okay. So Quantum is a 3-year-old uh, blockchain project. The blockchain launched in September 2017,
Okay,
and technically it's a combination of the Bitcoin UTXO model. Should I talk about UTXOs?
for sure.
Okay. Um, Let me come right back to that. UTXOs plus a layer on top of that of
Mm-hmm.
the Ethereum virtual machine for running smart contracts. And you can see our animated video showing there.
For
So
sure, yeah.
UTXOs are unspent transaction outputs. And it's a little bit of data. You can think about it as a file within a block on the blockchain. And that's where the coins or the value are kept on the blockchain.
Mm-hmm.
They're never coins in your wallet.
Okay.
Um, they're UTXOs on the blockchain in a block, and the wallet has the ability to move those around to spend them because it has a private key and can unlock those transactions so they can be sent. So an unspent transaction output, I guess, is the best kind because it means you can still spend it. So
For
it's
sure.
it's it's available to be used to pay for something or send to someone, or in our case, can be used for staking because Qtum is a proof of stake blockchain. So that's the other
Oh,
main
okay.
difference from
Bitcoin.
many other blockchains, including Bitcoin, Litecoin, things like that. Even Ethereum now are proof of work, which is a different kind of consensus mechanism.
So
Which,
we're trying to like, can we just go into that just real quick? I know that maybe the viewers do know what proof of work is, but in contrast to proof of stake and why that is interesting.
sure, and I'll give a little bit of a deep dive on quantum proof of stake consensus because it's an area that I like to study.
For
So,
sure. Yeah, let's do it.
proof of work, you get some very powerful computers like ASICs, and they do the hash calculations as fast as they can to
Mhm.
try and be selected as the next block producer, and also to win the block reward, which is the incentive for that.
Mhm.
With quantum proof of stake, though, it uses the same SHA-256 hash calculation,
Mhm.
but it does it just one time every 16 seconds for each UTXO that the wallet is staking.
Okay.
So if the wallet has 10 UTXOs or 100 or 1,000, every 16 seconds it's going to run through and do pretty much the same calculation that Bitcoin does,
Mhm.
where you take a hash and try to get under a target, and then you reach consensus. In quantum, it's called a kernel. Um, that owning that UTXO in that wallet and reaching consensus selects that wallet to be the block producer, publish the next block, and receive the block reward. So that's how proof of stake works, and
Mhm.
it's weighted according to the number of coins, UTXOs really, that you're staking. That determines the weight or the probability of how often that particular staking wallet would win a block reward. So, for example, a wallet that was staking 2,000 quantum would win a block reward twice as often as a wallet that was only staking 1,000,
Mhm.
if that makes sense. So it's really based on the value that's being staked, the value that's being committed to secure the network and operate and run the network through this proof of stake process.
Mhm.
If that makes sense. So that's the main difference. And I guess there's some variations in proof of stake um, consensus algorithms as well,
For
but
sure. For sure.
ours is fairly basic. In fact, from the time we launched, we've been running proof of stake through the Quantum Core wallet, which is a full node.
Mhm.
It downloads and syncs the whole blockchain, and then stays online 24/7 to run the proof of stake algorithm for its UTXOs and be that block producer and win the block rewards. But it was always, up till now, and will continue to be, a an online process with a full node. If you understand
For sure. Yeah.
that, that's sort of it. And it's not a super complicated thing that many people have run this full node and done staking. There's about 1,200 nodes right now that are operating in a little over 60 countries. So it's doable, but the downside is you have to be online, you have to pay for power. You should really have a
Yeah.
separate computer to run it for security reasons, internet connection, and you need to keep upgrading the wallet when there's new releases coming out. So
Mhm.
it takes some care and attention. And the motivation, what we want to talk about tonight, was offline staking protocol, which is this new approach for staking that Quantum is introducing this summer and fall, of offline staking. Not a great name from my perspective, but it really lets a non-staking wallet delegate by sending their address to an online wallet, sending the address with that reference to the UTXOs that are on the blockchain to another wallet that is online and can stake those UTXOs for that delegating wallet. That's
Yeah, that is
a mouthful. Did that make sense?
No, totally. Because what happens is the barrier to entry for staking your coin is elevated, and when you want to be a part of the community and then have like the ability to take part and not have that maybe not huge investment of time but also of investment of you know time and effort, is that if we're to go for the full node isn't necessarily something that everyone is apt to do, and the resource to do. So something that we've talked about and is that since it doesn't take any very little if any to CPU processing power, that you can do it on something like a Raspberry Pi.
Yeah, yeah. So the quantum proof of stake is very lightweight. In fact,
Mm-hmm.
it doesn't even run on a GPU. So it runs on a CPU. That's fine because it's only doing that hash calculation every 16 seconds. That's pretty leisurely versus Bitcoin ASICs are doing terahashes trying to solve that consensus algorithm. The quantum proof of stake is just doing that very leisurely. And so, yeah, you can run on a Raspberry Pi. I've done that. I've got a
Mm-hmm.
colleague who actually ran the node on a Pi Zero, which is like a little postage stamp computer for $10.
Yeah, I really thought that was cool.
Pretty easy to do. But having this proof of stake technology early on, blockchain up and running, um, as you were saying, it does take some commitment to run a full node. It helps if you're a blockchain geek or a tech geek because you're more interested to figure it out. But it's not for everyone. And one of the most common questions we would get from our community is, when can I stake on from my ledger? When can I stake on my ledger?
Mm-hmm.
Because using a hardware wallet is a best practice for security on blockchain. And a lot of
For
people
sure.
that didn't want to go through the hassle of running a full node or didn't trust it because there is malware out there
Mm-hmm.
and there can be problems. The safest thing is to keep it locked up in your hardware wallet. So a lot of people do that. So looking at the situation, a few years from when we launched in this spring, the core devs decided to tackle this problem and figure out how to modify the protocol, change the consensus to allow this delegation of address process that I talked about. It required changes in the protocol of the
Mm-hmm.
blocks of the transactions and some changes in the consensus layer. And um, they designed a new configuration and a new approach for the quantum core full node that you can configure and operate it as a super staker.
For sure.
And the super staker now can accept a delegation assignment through a smart contract. It monitors that smart contract. And when someone with another one of these non-staking wallets that has the ability to do that smart contract delegation transaction
Mm-hmm.
to say, here's my address, please stake the UTXOs for me and send me most of that block reward when you win a block reward for me. So they agree on it in advance on a little fee. The default is 10%. We'll see, where that ends up, people setting that.
Mm-hmm.
But with this approach, then the super staker, that's going to be the online 24/7 full node that's crunching through all the UTXOs that have been delegated to it through the address only, and staking those UTXOs on the blockchain.
Yes, you can see here on the screen, these are all the full nodes that are distributed right now.
Yeah, a lot of coverage in the U.S., in Europe, in Asia Pac, and then some more scattered throughout the world.
Cool. So this is in contrast to a full node. We're going to run a very light node for offline staking.
Yeah, so for offline staking, you just need a wallet that can do that smart contract transaction, which is a fairly prescriptive, standardized. It needs to know the address of the smart contract, the address of the super staker, its own address, and that's basically it. It just says, please stake these UTXOs for me, and I'll agree to pay you a 10% fee. And it's important to note that this is a non-custodial assignment. So the delegating wallet keeps the private keys, keeps full controls of the coins. They're just sending their address and then a signed message that says this proves that I've assigned my address to you to stake. So the user keeps full control of their coins, and the super staker stakes those UTXOs for a little piece of the action. So that's what the offline staking protocol does. Now, because it's a change in the block and the protocol and consensus, it does take a hard fork to implement this.
For sure, yeah. So let's see, delegating address to super staker. This is from the docs.
Okay.
So Qtum offline staking allows for the address for a non-staking wallet capable of making the delegation assignment transaction to be delegated to a super staker. Offline staking is a non-custodial, as like you were saying. The address delegation is made via smart contract. So we can see that the super staker accepts this fee and will begin staking the delegated address on transferred transactions.
Yeah, that's pretty much it.
So here's like a GUI here. You can see that Bob's big staker is the address.
Yeah, I should say too, this is the Qtum Qt wallet, which is a GUI. It has a nice user interface, very easy to operate. There's the 10% fee that I mentioned, the default fee.
Ah, yes, right here.
You know, you fill in a few blanks here, and you can make the delegation. Now we'll be using the command line version of the wallet tonight, so we won't be looking at these pretty screens here. We'll be down close to the bare metal.
For sure, yeah.
We're working on the blockchain.
On this program we don't shy away from that, so we'll try to try to keep the. So this is the script that we're talking about. This is the Qtum block ripper.
Yeah, let me go ahead and load that up. Should I show how to get the node up and running first?
Yeah, most definitely. Here, I'll switch over to you. Are you ready?
Okay.
Okay. Here we are, right there, the old command line.
All right. So, and maybe as I talk about this, you can simulate a download of the wallet.
For sure, yeah. We're going to do.
Your end, Eric.
Yeah, we're going to do a cooking show style. So I'm going to go through the process, and then what commands would you use to install?
Okay. Can I have a glass of wine like Julia Child?
Yes, you can.
Okay, so first we want to download and run the Qtum Core wallet. So if you can go back to that to the Qtum homepage and look under Product Wallet.
Hey, I'm back.
Oh,
I left for a little bit, but I'm back. Here you go.
Yeah. If you can go back to the Qtum homepage and look under Product Wallet.
Okay.
You'll see there's some different wallet choices, mobile and hardware, etc.
Okay, I'm going to share my screen again.
Okay, unshare me. Yeah.
All right. So if we go home, just
that's it. Okay, so product. Yeah, you get dizzy if you watch that too much, maybe. Wallet. And then what we want to choose here is the desktop wallet, although it will also give you the server version of the wallet. So Qtum Core, that's our full node.
Ah, okay. So this is the Qtum wallet. It looks cool. So you get that on mobile, web, hardware. Okay.
And then the choices are Mac, Windows, and Linux. On our GitHub, we have other versions available, but these are the popular versions.
For
So
sure.
if you were to click on Win64 there, it would start downloading the
Yeah, I just started
the
the
Windows
download.
installer, Windows executable.
Yeah, I think that we're going to be like, oh, I just installed it. I'm not going to show that screen, but I just hit install.
Okay.
So what happens after install? We can.
Yeah, so if you come back to my screen, I can talk through that then. When you run the install, it's going to, you're just going to double click on the downloaded file, and it would install the executables in your Windows program files directory in a Qtum subfolder. Now, let me see if I can show.
So you should be able to reach it from your path, correct?
Yeah, and it'll do a just like a standard setup. Now, what I like to do then is copy that over and put the executable files into a USB drive. I've called one here Q. Let me make this a little bigger so you can see.
Hey, we got a lot of people watching actually. Hey, there's a couple of people in chat. Cryptogal, Adam, Scott, Frederica. Hello. Welcome to the stream. I hope you're enjoying it right now. If you're just hopping on, we are installing the Windows version of the Qtum wallet, and we are going to be doing a hard fork to use basically the new testnet features of the wallet, which are offline staking.
Yeah, okay. So these are the executables that you get.
Okay.
There's the main ones that we'll be working with tonight are, this is the server daemon wallet here,
Mm-hmm.
Qtumd. Here's the GUI version that you were showing the screenshots of a bit ago. I'm
Yes,
sorry,
QT wallet.
Qt, and then we'll use this command line interface program here, Qtum-CLI. So we'll be using all those together. But to get the wallet going, we will launch it from the command line. And here
Great.
I'm over on the
The actual command prompt.
little hopscotch here. Yeah, hopscotch. So I would start up the wallet by listing its name, and then this next parameter says that we want to operate on testnet. Without this, it would connect up to the main Qtum network.
Okay.
And then also, because we're interested in offline staking, we'll say we want to use super staking, and
Okay.
then also we want to develop an index of all the transactions so that we can see see a lot of what's going on. So I'm going to go ahead and start this up. Now, this one is already running earlier today, because if you do a brand new install, the next thing that it would do is go and download and sync the whole blockchain.
Ah, yes. So that is one of the cooking show stalls that we're doing today. You were just like, oh, we're going to put this chicken in the oven, and we popped it right out because it's already done. So yeah, syncing will take like at least half the episode of watching it sync.
Yeah, it did more than that when I synced this one this afternoon. So it was almost 3 hours, but I took some did a little Photoshop of it. So up at the top here, I don't. It's not seeing my cursor. Oh well. In the top panel here, this is where we started. These are the commands I entered on that Q prompt for testnet, super staking, and TX index. And then it's going to, the node is going to connect up to peers and start downloading headers and then downloading blocks from the other peers. And it'll give an indication in this middle screen here. You can see some places it says progress, progress 0.18. It was 18% synced at that point.
Oh boy.
And then in the bottom screen, this is 2 hours and 50 minutes later. If you can, it's like a little mouse print there. It says progress equals 1.000. That's 100%. It's synced all the blocks. And now it's ready to start doing some some blockchain business. So that's the cooking show cake out of the oven that was
Yeah.
put in previously.
And we actually let it cool. Now we're ready to put the icing on top.
Right. So let's cut into that cake and do some work. So I've got a second
Just like another command prompt here.
terminal command prompt here. Yeah, I guess terminal would be more of a Linux term, but
Sure.
in Windows it's a command prompt. So we can try some different commands that we can give to the wallet or the node. And these are going to be roughly the same kind of commands you'd give a Bitcoin or any Bitcoin related node. There's a few extra commands added for quantum, for proof of stake stuff, and for super staking. We won't go through all that tonight, but I just wanted to give you a little flavor of what you can do. First, to see what all the commands are, you can do use the command line interface on Testnet and say help. If I could type, it would help. We can see what all the commands are. There's, I don't know, 120 of them.
Okay, so you can do everything that you would be able to do in the graphic wallet here, which is nice.
Yes, and some extra stuff for power users. But yeah, the graphical wallet makes it easy for beginners, and what I recommend is people get started with the graphical wallet. And then if you want, or if you want to jump into the cloud, run the node in a, at Amazon or something like that, then you can go to the daemon version that we'll be using here tonight.
Yeah, and that's another thing too to consider is that it's probably so lightweight you could probably run it in a free instance of Amazon.
Oh yeah, you can get
very small cluster.
you can get the first year of free service with AWS. It's really easy. It runs as, if I can remember right, as a T1 small on Amazon.
Yeah.
And you can set up a swap file, and it works pretty good. So anyway, you can get help whenever you want it. Let's try some actual
commands.
Commands, yeah. Get a little taste of that.
Sure.
So here we've got a lot of the commands will say get something, get balance, get address.
Okay.
Here we're going to get some info. Here's some basic info about the version of the node. Is 19.0.1.
Mm-hmm.
And the current block height, a little over 650,000. This node has 10 connections, which is the standard these days. And then I set it some test quantum earlier from the faucet today, so it has, I guess it's a little spender, maybe it's got 29 quantum.
Cool.
Test quantum to play with, and there's no warning, so that's a good sign. So that's just a very simple example of getting some information about this wallet. We can see that it's up and running, everything is working right, but it's not where we're going tonight. We want to get a little work done.
Sure.
So let me show you how to query a particular block. We want to say, we want to get the block hash, which is the ID, like the social security number for a particular block.
Mm-hmm.
Get block hash. And here's one I picked out before that I know will give us a good result. 649,970.
Okay.
So there's, can you see that okay?
Yeah, it looks good. So that's the hash of, that's the block hash.
Right, and that's going to be unique in all the world for this blockchain. If I can copy this guy.
Okay.
Hang on, let me kill. I'm getting slacked by my colleagues here. So next we can look up that actual block and get some more details about it now that we know its ID number.
For sure.
And I copied that, so I'll just paste it in. And I will also say Yeah, so that should do it.
Oh, okay, cool.
And this is the whole block header, just taken directly from the blockchain. So, excuse me. This is a local version of the blockchain that's in this computer
Mm,
that's identical with every other quantum node in the world that's running testnet right now. So it's my local copy of it, but it's guaranteed to be the same as everybody else.
mhm.
And I can interact directly with the blockchain, with the node here. There's no middleman. There's no central server somewhere that I have to rely on. This is my node talking directly to the local blockchain, which is in sync with the other nodes all over the world. Does that make sense?
Yes.
So it's really empowering if you're a geek and worried about central control, because there's no central control on the blockchain.
Yeah, so we have the hash, how many confirmations it has, the strip size, we have size, height, weight. It's like a person.
Yeah, and then there's some stuff here related to the smart contracts. This one here, this next one, pre stake hash. Um, that's actually the delegate that has uh, that has gotten the block reward from this from some super staker that we're gonna look at. And then next we have two transactions that are in this block. This first one here is called the Coinbase Transaction. That's left blank in quantum blocks. That's for a proof of stake block reward, and we don't use it. But the second one here, this is very important. This is called the coin stake, and that conveys the block reward on quantum chain. And then if we look at some other stuff here, some standard, there's bits and difficulty. Those are related to the the difficulty of solving for the next block. Some other generic information, but this is the one, this last one here was added on at the end because it's the recent change, is the one we want to work on tonight, and that's proof of delegation. So this is a signature that guarantees and proves that some non-staking wallet has delegated the UTXOs to this super staker, and so everything is copacetic, everything is fine. It's signed, it's proven that this is the correct approach. Okay, so far.
Great.
So to me, working with blockchain data is just a lot of string and character processing. I mean, all this is just, there's no advanced math or anything at this point. It's just characters and strings. So that's what we'll be digging into.
Okay.
And while I'm here, I'm just going to make a copy of all this because we'll use it in a little bit. Okay, so what I'm driving at this evening is I want to look at a number of blocks on testnet and see how many are being staked by these super stakers and how many continue to be staked by the regular stakers, the sort of solo stakers that will continue to operate. And to do that, I want to look and see how many of them have this proof of delegation field in it. Because if it's not a super staker, then this field would be missing. It would be gone because there's no proof of delegation. It was my staker, it mined from my UTXOs, it's my block rewards. Leave me
Okay.
alone. That's the deal. So I could go and type in 100 blocks and get the block hashes, and that would take me maybe 2 or 3 hours.
Okay.
And that would make for a pretty boring live stream. So instead, let's look and see how we can do it with a Python script.
Yeah, that's kind of like where we kind of like needed it, and that's exciting. Let's check it out.
Okay, so and what I do, I guess it's like PowerPoint or college essays or anything that you've written and build up a library of. I like to repurpose, some programs that I wrote before and just change those and adapt them to the situation. So let's do that. I'm going to go to my repository, GitHub repository, and grab a program that I had before, which was the blockchain Ripper that you mentioned, and I'll adapt that to use with this new protocol.
Yes, because we are on Testnet, not the normal.
Right.
the
So
normal
let me see if I can pick that baby up.
Okay.
Can you still see my screen because I changed away on the other?
I can see your 2 command prompts.
Okay, that's great. That's what I want. Okay, so I'm gonna move this over and hope to not break anything in the stream here. Does that look okay?
Yeah, can you just zoom in on that a bit? Yeah, maybe one less. Oh, that's fine. Yeah, one less is good.
Okay, 200%.
Yeah,
so here's a program I wrote several months ago. I was writing a blog about something. I guess maybe I mentioned the coin stake. I was interested in the values going into and out of the coin stake. So I wrote a little script to analyze that. And that's what we want to use tonight. I'm going to reuse this program, but tweak it so that it picks out that proof of delegation field to identify which of the blocks are from a super staker. So I'm just going to do this brute force. I'm not even going to download the file. I'm just going to copy it here.
Okay, cool.
I'm sorry, this is boring.
Oh, it's fine.
Wow, it's a long program. Come on. There we go. Okay. So we'll just copy that. And now I'm going to go back to where we were, and I'm going to just paste that into my text editor here. I'm not going to blow this up because we're going to jump into the Python IDE real soon here, and then it will be visible. But let me save this. I'm going to put it back on my Q drive. I find I put my Python script in the same directory as the executable because it wants to talk to that Qtum-CLI program.
Sure.
And the node is right there. And rather than figure out the paths and all that, I just put everything together in the same directory, and that works out pretty easy.
Yeah, it totally makes sense.
We'll call this superstaker.py for Python. And now we're ready to go. We just need to bring up the Python editor. And I'm using the Python IDE. Is that called idle? Is that the correct way to say that?
You know what? Yeah, your guess is. I've always just said IDE. I don't know if there's a an L there, so I wouldn't necessarily use that.
Well, okay. So I've launched it. This is Python 3.8. And this is the command line here, but I want to load that file. So let me go find it. And there it is, superstaker.py.
Okay.
And now it popped up on my other window. And there it is. Let me show you a few things about this program before we start changing it up.
Okay.
So this is the output it should produce here that I was investigating before. That's a block number, and then the input and output values for that coin stake transaction. Then,
so it looks like you're importing subprocess, operating system and sys.
yes, those are some libraries. Subprocess lets Python type on the keyboard to launch other programs and get the results back.
Mm-hmm.
There's a more sophisticated way of saying that, but that's what it does.
Sure.
And then OS and sys. I'm not doing any file operations in this program, but I do exit the program with a sys command.
Cool.
Let me show you a little bit of operating system trivia here. So that's actually wrong. I'm going to change that. This program would work under Windows and Linux, and I work in both environments. Mostly on Windows because I can. A lot of our community, our users, are using Windows.
Sure.
And so if I'm on Telegram doing tech support, which I love to do, I can do screenshots of my Windows wallet to show them in direct messages and stuff like that. So
yeah, hopefully you can just send them over to this video.
okay, yeah, go watch the video and then call me later.
Yeah, it's like, I don't know how many screenshots this is, but there's like 60 of them per second.
That's quite a few, yes.
Yeah.
60 frame, that's great. The difference though between Linux and Windows is Linux, the commands in terminal, you reference the current directory with a /. Well, for Windows, you don't have to do that. You just have to be in the right directory. And so it's a null string.
Okay, yeah.
So I've got a little switch there that will let this program run on either Windows or Linux.
And something else to remind you when working cross-platform, and I can see it right there where it says balance. It says, for example, to find the balance from Qtum.
I know where you're going. Yeah.
Yeah, you have the CRLF ending, the R/R. Windows type style endings.
So Windows gives you, I would call that a carriage return and a line feed. I'm not sure if that's exactly right.
Yeah, CRLF.
Okay, Linux would just give you the line feed. So if you're counting numbers through that text, Windows, you got to count a little more before you find the next field. If you're doing it, and that can be a big hassle until you figure that out.
For sure.
Don't ask me how I know this. Then I've got, how does this go?
So it looks like you're creating
what am I doing here? Yeah.
a big old loop here until the block is less than to the end of the block. So you're going to get the block hash. That's something we did earlier.
Yeah, so this program is going to start out doing exactly what I did on the keyboard. So the first thing it's going to say, give me the block hash for a particular block number.
Okay.
Which we did.
Yes.
Then it's going to, here's the way I write these programs with sort of debugging and data response as comments. It's going to get a hash back, and then it's going to it's going to extract that block hash and then use it in the get block command. And then that is going to produce this big blob of data that we saw before that I made a copy of. I probably lost that copy.
So this is examples for block 300,000.
Yeah. So this was a while ago. And then this program is going to go on to, here's we just talked about this. This is that difference with the CRLF new line in Linux versus Windows. So there it's making that adjustment for that difference. But this program is going to go on to extract the second transaction, which is the coin stake, and then search through and find a value field, get the value of the coin stake. We're not going to look at that tonight. That's a little more complicated, and
for sure
we'd be here way too long. So let's go ahead and just run this and see what happens, because it was a pretty decent program when I posted it. It worked pretty good, so it might still work now. Let's see. Okay, we'll have to save the source because I corrected that one comment. So here it is running, and it says, it tried to reference a variable in this first very first command that it did. It was trying to get this variable block hash raw with that 64 character string of the block hash, but it couldn't get it. And I happen to know, because I've made this mistake ever so many times,
Okay.
that it didn't reference testnet here.
Aha.
So you see, this would be on mainnet, and of course it can't find that block on mainnet because it doesn't exist. So we have to put in that testnet parameter there and there. I think there's 4 of these, although we're going to get rid of some of these soon.
Okay.
There, I think there's 1 more. Okay, let's see if this works a little better now. I should save the file. Okay, that's better. So it's starting at block 5000. It did 10 blocks. The formatting is a little off here, but basically it's doing what I expected. It's saying that there was some input value to the coin stake, some output value. And so we're at a place now where we can work with this program. It's running. So let's fix it up to work to identify that proof of delegation.
Okay, cool. What's the
So
first step?
that is a good question. The first step is to scroll up.
Okay.
Actually, the first step is I want to, I'm kind of anal about this. I want to put this block result back in so that we can see what we're working with.
Sure.
So let me copy that, and we're gonna, because the protocol has changed, right? So I should put in the new result.
Okay.
And there it is, and it's not formatted. So I'm just going to do.
We'll do word wrap or something.
I'm going to do some deletions so we can get it. Normally I would say something like this, a snip. Anyway, that's good enough. Now we can see what's going on. There's our proof of delegation field for this block that we saw before from the command line. And otherwise, the rest of it is going to be pretty much the same. This was 203 blocks ago. And it's block 649997. Well, that was when I did it from the command line.
Mm-hmm.
So what I want to do is pick out this proof of delegation and see if that's in a particular block that we're looking at. So
Okay, cool.
let's go and because we know it's going to work on this block. I'm going to go back up to the very top of the program and put this block number in here as the starting block. And just to get started, let's only do 1 block. So I've got this set for block 649970. And now, when I come down here, I want to find in this block data whether I've got a proof of delegation field. So previously I was finding the transactions that start with this brace, but I want to find proof of delegation. So let me just say, and you know this find command, you know how that works?
Do I know how it works under the hood? No.
Well, I don't either. But
I was like, well, how does it work?
the result is, though, if it can find proof of delegation field in all that data, it'll return the number where it starts. And if it can't find it, it'll return a -1. So let's see if it can do that. And when when I'm writing programs, I find it best to go like one step at a time very carefully, make sure each step works right. Maybe run some unit tests on it or something, and then I'll go on. So I'm just going to see, for this block, can we find that proof of delegation field? And if so, we'll print out the location where that is, and then we'll just stop the program, because
Okay.
that's enough for one step.
Okay.
Well, that looks pretty good. It's at character position 1598. So it finds it there.
Okay, cool.
Does that make sense?
Yeah, because what you're saying is that you got that response back and you found it and it's at that position, so you can start doing your text analysis.
Right, right. And if I was going to, for example, grab that proof of delegation and do some processing on it, which I don't know how to do, but then I would go to that location and grab it. Let me just check one other block to make sure this is working right. I'll just pick the next one, which I happen to know is not a superstaker block. And we'll run the program and see if it works correctly for that. And yeah, it says -1, which means it couldn't find a proof of delegation field. So this is a plain vanilla staking node that doesn't have a delegation or any fancy stuff like that. All right, so let's go back to this. We're almost done. We're like 2 minutes from being done with this. Now we'll just do something something useful with this single block at a time thing. I'm going to just unceremoniously delete all this other text. I could comment it out in case I need it.
Let's just get rid of it.
We'll just get rid of it because we don't need it. And instead, let's just do some simple output. We're going to say if I is greater than or equal to 0, that means we found a proof of delegation field. We're going to set a variable say, yep, we found a superstaker. Otherwise, we're going to say temp equals a null string because it's not a superstaker. And then we can print out the block number and that superstaker or not. And then, because we're at the bottom of the loop here, we're going to increment the block number so we can get another block. Does that make sense?
Yes.
So, I mean,
At least it makes sense to me.
This is like the simplest thing that you could do with this information.
Yeah.
But once you got this set up, you could go from here, extract any data in the block or the blockchain or the transactions, run any kind of analysis on it. The ultimate version of this is an explorer, which takes all the data and presents it in a very beautiful, understandable format. But if you're doing some back-end processing or something like that, or you're building an exchange or something, you're going to want to go in through a node and do all this processing yourself. So we'll start with that block that we had before. We'll go 100 blocks, and we'll see how many of them are super stakers, and then we'll be done. Well, this doesn't look good.
Oh, we got a couple.
No, but it's not.
How's I-1?
That means it didn't find it, but that's not. I just wanted to just print the block number. So I messed up somehow. Let's see.
Yeah, no problems. This looks good.
Oh, this was my debugging statement there. So this should look better now. It's just going to print the block number and superstaker or not.
Okay, cool. Yeah, beforehand it was just doing everything.
Yeah, I left my debug statement in there. Okay, so here we go. This should be the result I was hoping for.
Okay, so everyone who's watching, we got a lot of people in chat actually. So hello, And right now we are doing live coding, searching the quantum blockchain for super stakers.
Ooh, 4 in a row. Nice.
Wow. So we're doing this live and it looks pretty cool. Great. So, we could probably run a counter, but yeah, these are our super stakers. And you could probably go on from this and say, what is that super staker address, and make an address book out of it, or
Exactly. Yeah, you can, and I've done this. I have some on my repository, ways of identifying the delegator, the super
Mhm.
staker, and do further analysis of it. But this was about the simplest example that I could try to get through in 1 hour that would hopefully make sense to you and to people that are watching.
Yeah, I mean, just like as a recap, what we did here was show that the new features of the testnet are going to allow us to basically answer some of the questions that have been going through the community and say, yeah, I would like to host my own, light node in a way, so I can be a part of it. And because really, what other cryptocurrencies like, you want to be able to have your custody of it. You want to be able to like own your crypto at the end of the day that has your key. And this is a way that you don't have to have you can host it on something what we mentioned earlier, like a really like cheap computer if you don't have like a lot of resource, or if you want to just like run it on an AWS account. You can take the new the new features of the quantum blockchain and own those changes. And some of these problems come up, which I hope other people will come back to the stream and look at this, and you can see our step-by-step process, because I really did think you did a really good job of at least showing some of the basic commands that you can do right from the command line.
Yeah, I tried to keep it very basic to show how to launch the server node, the daemon node, how to interact with it from the command line, and then just the very minimal, easiest way to interact with it with a Python script. And then from here, if you can do this, as we said, you can advance to much more elaborate ways of processing the blockchain data and doing something interesting with that.
So I'm going to take over the screen again, so you can see that these are the wallets that that you're currently on.
Yeah, I'll just do a shout out to Atomic Wallet there. We're doing an AMA with them tomorrow on our
Oh,
Telegram channel at, I want to say it's 10 a.m. Eastern, and they'll be one of the first third-party wallets to introduce this offline staking delegation function.
all right. This is the atomic wallet. Great. So you're gonna do them with them. Try to go back. It doesn't want to go back. Let's see.
Okay, we'll end up on Atomic Wallet tonight.
Oh, that's fine. Now we're back here, and you're on Binance, Bitfinex, Bithumb, Bittrex, Huobi, Kraken, OKX, Poloniex,
Too
Upbit.
many exchanges to count.
Yeah, for sure. Yeah, this is what we were on.
So those are the highlights, and you saw me make, sometimes intentionally, sometimes unintentionally, the common mistakes that I encounter setting up the Python environment. You want to make sure you're talking to the right blockchain, whether it's testnet or mainnet, otherwise it won't work. A little bit of that business with the difference between Linux and Windows, that's another uh, trap that I'd fallen into enough times that I put it in my comments so I remember. Another one I didn't call out there was not turning on the TX index parameter, because that lets the node query any transaction on the blockchain, not just the ones that it originated. So that's just a startup parameter for the node that gives it a more global vision of the blockchain.
Cool. Yeah, I've learned a lot today, and I really hope that everyone who's listening tries to spin up an instance of Python. It looks like that Python script didn't have any particular dependencies that you needed to install. So it looked like they just had something right out the.
Right. Yeah, I try to keep it plain vanilla. There's some stuff you could do for Windows if you want to make sounds and things like that, but to keep it generic to work on Linux too, I just made it plain vanilla.
Great. Let's see. Well, thanks, Jackson, for coming from Qtum. I'm Eric from the Blockchain Center. I hope everyone enjoyed and thought tonight. If you really like the content, we have all the links that we were doing right down below. If you can give us a like and a subscribe, that'd be great. Ring those bells so you can get notifications here for each and every time that we want to go live. We have Trading Tuesdays, Crypto Mondays. I'm here on Dev Wednesdays, and we are signing off. Thanks for coming.
Thanks a lot, Eric. It was great, and I look forward to visiting the Blockchain Center in Manhattan once you get all the sand mucked out there.
Yeah, that'd be great. Yeah, we can hang out, and we'll be there with Nick and the crew.
Very good.
All right.
All right. Thanks a lot. Take care.
You too. Bye.